Hello geometry students, welcome back to Mr. Farina's geometry class. Today we extend our lesson about parallel lines and all the different angle relationships that we get with parallel lines. And it's an extension of the GeoGebra activity, kind of stepping up the level of difficulty with the problems and so on. So let's begin. What do we call lines that are coplanar and never intersect? Well, if you remember, we had two types of lines that never intersect. We had skew or parallel. When we refer to coplanar, all right, that's what tells us that we're dealing with parallel lines. Okay. Now, a symbol for parallel is just a little symbol like this, two, forward slashes. Okay. If you remember all the angle relationships we talked about the other day, such as 3 and 5, 4 and 6, alternate interior, 2 and 6, 1 and 5, 4 and 8, 3 and 7, those are all your corresponding angles. And then you have your 3 and 6, which are same side interior angles, 4 and 5, which are your same side interior angles. We talked about all those angle relationships. And the other day when we did the GeoGebra activity, we discovered, properties about those relationships when lines were parallel. So first one was, if a transversal intersects two parallel lines, then the corresponding angles are congruent. Alright, if you remember in your sketches, corresponding angles have the same measure, which means we say they're congruent. Then we talked about alternate interior angles. When lines are parallel, what do we conclude about those? They are congruent. Alternate exterior angles are congruent. And then we said same side interior angles are supplementary, which means they add up to 1/8. And then as we continue, we had same side exterior angles, which were supplementary also. So how do we put these into, examples? Well, when you look at example 1a, right, we're looking for the measure of angle 5. What relation does it have in terms of the 80 degrees? Well, these are same side exterior angles. Okay, or sorry, same side interior angles. And with it, up above, what do we say same side interior angles were? We said they were supplementary. So if these two angles are supplementary, we're going to say angle 5 is equal to 180 minus that 80 degrees, and angle 5 is 100 degrees. Done. Alright, so when it says to justify a reason, we say if parallel lines, then same side interior angles are supplementary. Alright, looking at the next one. Angle 8 and this 42-degree angle. Alright, what do we notice about those? Those are alternate exterior. If this is my transversal, they are on opposite sides of the transversal. They are both exterior, so they're alternate exterior angles. What did we say up above that alternate exterior angles were when lines were parallel? We said alternate exterior angles are congruent. So angle 8 is 42 degrees right away. Okay, now angle 2 and angle 1, the 145 degree, when you look at those, first identify that both of them are on the same side of the transversal. Same side of the transversal, one interior, one exterior, and they are non-adjacent. That means they're corresponding angles. What do we know about corresponding angles when lines are parallel? We say that they are congruent. So angle 2 is equal to 145 degrees. And that is it. Now again, when we justify our reason, we have to state if lines are parallel, then corresponding angles are congruent. Okay, you have to state lines are parallel, because if lines are not parallel, those angles would not be congruent. Next, find the value of the variable in each problem. When we look at these two angles, what relationship do they have? These are basically corresponding angles. So if corresponding angles or sorry, if lines are parallel, then corresponding angles are congruent. And if these are congruent, we set the measures equal to each other. X plus 15 equals 125. And when you solve for x, you get 110. Okay, example B. When you look at it, what relationship do these angles have? These are same side interior angles. And if we look at the theorem above, if lines are parallel, then same side interior angles are supplementary. So our setup in this case, if they're supplementary, that means they add up to 180. So x minus 2 plus 78 equals 180. And now x plus 76 equals 180. X would be 104. Now that's not the measure of the angle, that's just the value of x. Okay. So when we look at this, next example, example 3. If I go to find the value of x, if I highlight these are my parallel lines, and now I'm going to look for my transversal. What line touches them both? It's that one there. Well, if you look at these angles, right, they are on the same side of the blue transversal, and they are both interior angles. So we know that these are same side interior angles. So what do same side interior angles do? They add up to 180. So 5x plus 4x equals 180. Now I can go ahead and solve for x. And x is equal to 20. Now once we know the value of x, I can plug it in. 5 times 20 tells me this angle is 100 degrees. And if these are supplementary, I can either plug x in, or I know they have to add up to 180, so that's 80 degrees. Alright. The next one, we have to find the value of x and y. Okay, so if I'm looking for, say, y, I'm going to focus on these two angles. Now, do we need to use parallel lines to find y? No, because if we look at these two angles, they are a linear pair. And what do we know about linear pairs? They add up to 180. So y minus 1 plus 35 equals 180. So y plus 34 equals 180, and then y equals 146. Now to find x is a little more challenging. There's two ways to do it. One, I know right away that if this angle here is 35 degrees, then I could potentially find any angle I want. I know these have to add up to 180, so this would be 145. This angle would be 35 degrees because these are alternate interior angles. So now I have two choices. One, I can use, if I wanted to, I can use that these two add up to 180, or I could use these two are vertical. It does not matter. The setup I like to use is 3x plus 1 equals 145, and I'm using the vertical angles to figure this out. So 3x equals 144. When I divide by x, x is equal to 448. Okay, now if you wanted to, you could also set it up as 3x plus 1 plus 35 equals 180. Either one of those setups would work. You'll get the same answer. Okay, example 5. When you look at this problem, you're going to see these type of problems on the ACT test. And when you see them, it's very important to know how to approach them. You don't have to find them in alphabetical order all the time. But if I highlight the parallel lines, like such, I'll notice that angle A and this angle here, if I highlight that red line, they're on opposite sides of the transversal, and they're both interior of the blue parallel lines, which means those are congruent. So angle A right away is 65 degrees. Now, angle C, if I highlight this angle, right, and then I highlight this angle, they both touch this transversal and they're in between or interior of the two blue lines. So angle C in 40 degrees, that is going to be alternate interior angles. So that would be 40 degrees. Well, we still have to find B. Well, there's two ways to find B. We're going to take the one approach we know right now, and that is, what do all three of these angles have to add up to? So if I go ahead and look at it, what do all three of these angles have to add up to? And that is 180. So we're going to say B is equal to 180 minus 65 minus 40, which tells us B is going to be 75 degrees. Okay, and that's using that A, B, and C all have to add up to 180. Alright, and a couple more here. Example 6, if I look at this, if I highlight the parallel lines, and that is sometimes key, right away I'll notice that if you look at X and the 70-degree angle, both of those touch the yellow parallel lines, and they both touch this transversal. And if you look, they're on the same side of transversal, one interior, one exterior. So right away, X and 70 degrees are corresponding angles, so X is 70 degrees. But we still have to find Y. There's two ways to look at it. The easiest way is to know what all three of these angles add up to. Okay, and that would be Y equals 180 minus 50 minus 70, which is 60 degrees. The other way is to know that, let me change the colors here, that these two angles put together and this angle here, they have to add up to 180. So another setup to find Y is to do Y plus 50 plus the 70. These are same side interior angles, so they have to add up to 180. When you solve for Y, you get 60 degrees. So there's a couple different ways to approach that problem. Then this last one. This one's a little more challenging. If you look, you can't add X and Y up to 180 because you'd have an equation with two different variables. So how do we approach it? Well, we see two angles that have Y in it. And if I look at those right now, they have no relationship that we talked about. They're on opposite sides of the transversal, right? And if I highlight the parallel lines, one's inside, one's outside, so they're not corresponding, they're not alternate interior or alternate exterior. So what could we do? Well, any angle we know is congruent to this angle, Y here. And we know this Y and this angle here, these are going to be congruent because those are alternate interior angles. So once I fill that in with Y, then I know right away that these two angles are going to add up to 180. So to find Y, we would do Y plus 3Y equals 180. So 4Y equals 180, Y is equal to 45. Once I know Y, now I know X and Y over here. Now I have to add up to 180. So X plus 45 equals 180, and X is equal to 135. This should give you a good idea of how to start the parallel lines homework, and be ready for the quiz on Friday. See you in class tomorrow.